The sorting algorithm we choose can depend on our data type. Using the squim sort tool, we can sort 50 items with merge sort, and each time the number of comparisons is the same because merge sort is stable. Thing is, even though we have relatively few comparisons compared with our worst case scenario, the tool doesn't take into account the extra space that merge sort requires. The spreadsheet was created using the squim sort tool. As you can see, for reverse data, both quicksort and insertion sort have a similar number to selection sort, making this the worst case. For quicksort, random data is our best case, and for insertion sort, nearly sorted data has the fewest comparisons. Let's see just how much better quicksort is compared with selection sort for our random data. What I've done is I've divided the number of comparisons needed by selection sort with that by quicksort, and that tells me that for 50 items, quicksort is 5.5 times as fast. If I was to go over to 100 times, the question we're asking is, would it still be 5.5 times quicker? And the answer might surprise you. It's actually 7 times faster. If I copy that formula down, we can see that by the time we get to almost 1,000 items, quicksort is almost 50 times faster than selection sort. As we increase the number of items, quicksort becomes more and more effective compared with selection sort. The best case for insertion sort is nearly sorted data. When we compare insertion sort with selection sort, we can see that insertion sort is much quicker, going from between 40 to 60 times. But unlike quicksort, it's not getting better and better, it's staying pretty constant. So the final question is, should we be using quicksort or insertion sort? What we can do is we can compare the best case of each and see what happens. For smaller numbers, if you're going to go insertion versus quick for your best case, insertion is 7 times more effective. But as we increase the number of items, that efficiency of quicksort really starts to come into its own, and at a certain point it is going to overtake insertion sort as the best option. We still have the question on what to do for our reverse data. We could use merge sort even though it requires more space, but a better option could be to use quicksort but randomly choose the pivot. And it turns out that by randomly choosing the pivot, we can overcome that problem of reverse sort being the worst case, because once we randomly choose the pivot, it's pretty much the same as having random data.